This is the fifth in a series of videos on the sampling distribution of p-hat. And in this problem we want to do a sample problem here, but let's first revisit a problem that we did previously. And the problem that we did previously said let the proportion of students who like baseball be 60%, and we found the probability of a sample of 40 students that more than one-half like baseball. So we're going to look at a slightly different problem. So let's start with the same premise. That is, the proportion of students who like baseball is 60%, and then say what's the probability that if you take a sample of 45, that in your sample between 55 and 65% of the students in your sample like baseball. So again, in this case, mu is equal to 0.6, and we're going to find the probability that p-hat in a particular sample is between 0.65 and 0.55. That's what we're trying to figure out, that probability. So first let's look at the sampling distribution of p-hat. Now what's confusing here is p-hat can mean two things. It's both a particular value, right, that are particular values between 55 and 65, but it's also an estimator, a process, right? So for p-hat, the estimator, we know that mu p-hat is equal to the true value, 0.6 p. And we can also figure out what sigma p-hat is. Sigma p-hat is going to be the square root of p times 1 minus p over n, or the square root of 0.6, 0.4 over 45. And let's just use a calculator to calculate that. And I get about around 0.073. Right? So I have a mean and standard deviation of distribution. Now what I want to do is I want to take two p-values, right? So the two p-values, let me write that down real quick. Mu p-hat is equal to 0.6. Sigma p-hat is equal to 0.073. And what I want to do is I want to take a p-hat of 0.55 and I want to find the z-score. And then I want to do the same thing with p is equal to 0.65. So let's see if I can do both of these the same together. So the formula here is going to be that z is equal to, in general it's x minus mu over sigma, but with p's it's going to be p-hat minus p over sigma p-hat. In this case 0.55 minus 0.6 over 0.073. Let's make sure what we're doing here. We have a given value of p-hat, but we want to find the standardized value, or the z-score. So we do is we take the sample value minus the true population value divided by the standard deviation of the estimator. And then we just do that on our calculator. So let's do that on our calculator. 0.55 minus 0.6 divided by 0.073, and I get minus 0.68. Let's do the same thing with 0.65. So then you use the same formula, right? So you don't have to memorize this formula right now. If you use this with your notes, you'll do these problems enough so it kind of becomes second nature to you. So you get p-hat minus p over sigma p-hat, which in this case will be 0.65 minus 0.6 over 0.073. And that's going to be 0.68. Now, in this particular case, we see that these two are equal. That won't generally be the case. Now, my two z-scores. What I'm going to do is I'm going to draw two normal distributions. The first one is going to be for p hat, the estimator. That's 0.6, and I'm going to find the probability that you're between 65% and 55%. So that's what I'm trying to find right there. But I'm going to do it with a z-table, so I want to translate that to a z-distribution, where this is 0, and this is 0.68, and this is minus 0.68. So that's what I'm going to find right there. So what I'm going to need is I'm going to need to use the z-table to try to figure out what this is right here. That area right there. And that takes a little bit of practice, but this is basically the way that I'm going to do it. I'm first going to find, remember the z-tables are always done on area to the left, so I'm first going to find this amount right here. That is the probability that p hat is less than 0.68, or z, actually. The probability that z is less than 0.68. Let's look at our table. Now here, I've used negatives before, so now go to the other side. I use positive, and I look at 0.6, but then I have to go over to 0.68, and let's see if I can do this successfully. 0.6, 0.68, that's 0.7517. But if you notice that, I've got too much there, right? That gives me all of this value, right? This gives me all of this, but I don't want this value here, so I'm going to lop that part off. This is negative 0.68. I'm going to lop that part off right there. And I'm going to use the table again, but here I'm going to use the negative value. I go down to minus 0.6. But then after I get to minus 0.6, I'm going to have to go over to 0.8. So I'm probably going to need a nice sheet of paper here for this. 0.6, 8, that's 0.2483. Probability of z is less than minus 0.68 is equal to 0.2483. Now let's just use our geometry here for a second. If the probability that you're less than 0.68 is 0.7157, and the probability that you're less than negative 0.68 is 0.2483, the probability that you fall between those two is going to be 0.7517 minus 0.2483. And I'm going to use a calculator for that. In my younger days, I would try to do that in my head. And I get 0.5034. In other words, I have around a 50% chance of the number of people in my sample, right? But there is a problem. In my particular sample of 45, then I have a roughly 50% chance that between 55 and 65% of the students will end up liking baseball. And then I'm finished.